Okay, let's start with a wild question. What if our energy grid had a brain? I mean, a real digital nervous system that could see, think, and react to everything in real time. That's the incredible idea we're exploring today, how these intelligent data platforms are completely changing the way we power our world.
Just imagine that for a second. A power grid that doesn't just react when there's a blackout, but actually sees it coming and prevents it. A system that literally understands the journey of every single electron, making sure it takes the most efficient path. This is the core idea we're going to unpack, turning our old-school energy infrastructure into an intelligent, self-aware network.
So, what do you call this thing? The term is a digital nervous system. And listen, this isn't just another dashboard with a couple of charts. No way. This is a full-blown intelligence platform. It's designed to connect and control the entire energy ecosystem from the second power is generated all the way to the plug in your wall.
So how in the world do you build something that ambitious? Well, you've got to start with a really clear mission, and that mission is broken down into 5 key strategic pillars. These pillars are the foundation. They define exactly what this digital brain is supposed to do.
First step, transparency. Getting a totally unfiltered look at the entire journey of energy. Second, optimization, making every single piece of equipment, every turbine, every transformer work smarter and last longer. Third, control, hunting down those hidden energy leaks and preventing super costly failures. Fourth is financial intelligence, understanding the true cost and profit of every single kilowatt. And finally, sustainability, being the engine that powers the switch to green energy. You put these 5 together and you get a complete 360-degree command center for the entire energy value chain.
Okay, those are some massive goals, right? So how do you actually make them happen? You need an incredibly powerful engine driving all this intelligence. And that engine is something called a digital twin.
Which, of course, leads to the big question. How can a digital system possibly see and understand a huge, sprawling physical energy grid with millions of miles of cables and thousands of pieces of equipment? Well, the answer is pretty cool. It lies in how it creates a perfect model of reality.
So, the core architecture has 2 main parts that work together. First, you have the digital twin, which is a perfect one-to-one virtual copy of the entire physical system. Then you have the data lakehouse, which is this giant library where every bit of information from that system gets stored and analyzed. So think of it like this. The digital twin is the virtual body, and the data lakehouse is its entire memory.
Now, this model is built up in layers. At the very bottom, you have the infrastructure layer. This is where you create a perfect digital copy of every single physical thing, every power plant, every solar panel. Then, the next layer up is the measurement layer. This layer attaches all the real-time data from every meter and sensor right onto that digital copy. So you don't just have a picture of the object, you know exactly what it's doing right this second.
But it's not just about the machines. On top of those first 2 layers, you add the human element. The operational layer tracks every action people take, every maintenance order filed, every alarm that gets a response. And then the demand layer looks at us, the end users, analyzing how and when we're all using that energy. So now you have a complete picture of both the grid and the people who depend on it.
Okay, so we've collected a truly insane amount of data. But you know, data by itself is just noise. It doesn't mean anything until you can measure what really matters. This is the part where we turn all that raw data into actual intelligence. And we do it with a clear scorecard for success, built on what we call key performance indicators, or KPIs.
And having this intelligence allows for a massive strategic shift. I mean, a total change in philosophy. We get to move away from the old way of doing things, which is reactive maintenance, waiting for something to break and then scrambling to fix it. We move to a new model, predictive maintenance, using data to see failures coming before they happen. And honestly, this is a complete game changer.
Now, the really important thing to get here is that these KPIs aren't just abstract numbers on a screen. They are specifically designed to answer the biggest, most important business questions. The asset operations KPIs directly answer, hey, is my equipment about to fail? The financial KPIs tell you, are we actually making money here? System efficiency KPIs pinpoint exactly where the grid is leaking value, and sustainability tracks whether you're hitting those crucial green energy goals.
And it gets even more powerful from here. Because the next level of KPIs, well, they're driven by artificial intelligence. Now, we're not just reporting on what happened yesterday, we're actively predicting the future. Metrics like an asset risk score can tell you the exact probability of a failure, or remaining useful life. That tells you how much longer a part is going to last before it needs to be replaced. This is true predictive power.
So, let's get down to it. What's the real-world impact of all this?
What do all these fancy models, all this data, and all this AI actually deliver at the end of the day? What are the results you can actually touch and feel from an AI-powered energy grid?
Let's start with a massive number. Just by predicting failures before they happen, a system like this can slash asset downtime by 20 to 40%. Think about that. That means way more reliable power for all of us and a huge reduction in lost revenue from outages.
Next up, the bottom line. We're talking about a 10 to 30% reduction in overall operating costs. And that money is saved by optimizing maintenance schedules, cutting down on expensive emergency repairs, and just making the whole system run more efficiently.
But you know, it's not just about saving money. It's also about creating more value. The system actually drives a 15 to 25% increase in asset performance. It squeezes more power and a longer lifespan out of every single piece of equipment on the grid.
So how does the AI actually pull this off? It's through really specific jobs. Load forecasting uses machine learning to predict energy demand, which helps avoid buying super expensive power during peak hours. Predictive maintenance, like we've talked about, uses sensor data to see the future. Anomaly detection uses AI to spot tiny patterns that could indicate theft or a leak. And failure prediction builds risk models for the entire system. So let's bring it all home. What's the final bottom line here? What does all of this really add up to? It's about a journey. A journey from just having a bunch of data to achieving real strategic dominance in the energy world.
There's this quote from the source material that just nails it. This isn't just a BI system, it's an energy intelligence platform. It's not for making charts, it's for running the entire operation. So here it is, the ultimate value proposition, all in one place. It drastically cuts costs. It maximizes the value and life of your assets. It minimizes energy loss and system failures. It makes the whole grid more reliable and safer. And, this is huge, it speeds up the transition to green energy by making things like wind and solar more predictable and easier to manage.
And that leaves us with one last big question to chew on. As our world keeps transitioning to green energy, our grids are getting way more complex with solar, wind, and batteries all in the mix. And the demand for clean, reliable power is only going up. So is this level of intelligence no longer just a nice-to-have, a competitive choice, but an absolute necessity for the future of energy?